Good morning, students. Tuesday morning, March the 24th. Today I'm going to be doing lesson 100, and the problem sets that are on the left there. I will be doing 1, 2, 4, 7, 9, 11, 20, and 21. That's 8 problems out of the 20. First, let me just tell you what you need to be sure to bring to the school at 2:30 today when your parents bring your other lesson to be completed. All right, number one, bring all the completed lessons 95 to 100 so that I can score those and it'll be part of your test score. Bring your 2 completed reviews. Those will be part of your bonuses. Make sure you bring the 2 completed reviews. And finally, your completed test 10. All right, here we go. Problem number 1, lesson 100. We have a Bosch had a 40-meter head start, and Luis, he's trying to catch up. Here we go. This is a distance problem, and Bosch had a 40-meter head start. So in other words, he started off here 40 meters ahead of Luis. Distance of one, distance of the other. This is Bosch. He started here 40. I'm going to fill that in so we understand that, and this is Luis. All right, so here we have a RT equals RT plus 40. And of course, this is Bosch, and this is Luis. What do we have? We have Bosch, Luis traveled at 10 meters per second. This is Luis, he traveled at 10, and Bosch only had 6. Now we have the times, and let's read that closely. What do you think on the times? If I'm reading it, they both started at the same time, even though they were apart. They both started at the same time, and they ended at the same time. So when you have that these 2 times equal the same, they're interchangeable. Remember that? I can put TB where TL is. I can put TL where TB is. They're interchangeable. That's the key on this time. So in this case, I can do it either way, but I'm going to choose to put TB over here, and now I have TB plus 40. That makes sense? All right, now we got the 2 times, and combine those that would be 4 TB equals 40. Divide the 40 by the 4 here, so the time of Bosch equals 10, and they were both the same, so both of them equal 10. Now what is that? Read back through that problem, and I think you were talking about seconds. So the time of both of them was 10 seconds. There is your answer. That is number 1. Second problem here then is also a distance problem, so we'll put the 2 lines up here for our distance. Let's see. Robert ran to the redoubt while Wilbur walked to the parapet. Both distances were the same. They tell us that emphatically. Both distances were the same. So we just follow what they're saying. We have distance here and a distance here. This is Robert and this is Wilbur. Simple enough, isn't it? RT equals RT. This is Robert and this is Wilbur. What do we have here? Robert's speed was 6, and Wilbur's was 8. Again, we're looking to see about the time. Now we see the time is difference here. What is the difference here? I'm just going to start off with putting TR equals TW. One of them was 2 hours longer than the others. Whose was the longest? Robert's time was 2 hours longer. So to make these equal, balance out, I need to put 2 over here to make it balance out. Is that right? So now I have TR right here is actually TW plus 2 equals 8TW. Do the distributive property. I have 6TW plus 12 equals 8TW. Combine the times together and we have 2TW equals 12. Divide the 12 by the 2 and TW equals 6. 6 what? 6 hours. I believe we'll read through that. It says 6 hours. Okay, so if TW equals 6, then TR equals 8. Just an interesting side note, Robert was running and Wilbur was walking, and it took Robert longer than it did Wilbur. Must be something about the name. That was number 2. Number 4. Penelope and Miranda found 4 consecutive odd integers. So here we go. Odd or even, you skip every other one. N plus 2, n plus 4, and n plus 6. 1, 2, 3, 4. 5 times the sum of the first 2. 5 times the sum of the first 2. We have n plus 2 was 5 less, so we need to add 5. And it's 19 times the fourth, n plus 6. 5n plus 5n is going to be 10n plus 10 plus 5 equals 19n plus 19 times 6 is 114. Combine the ends. This looks like 9n. Now we have 15, and we put this on the other side. That would be a negative number, negative 99. Divided by 9. N equals negative 11. And 4 consecutive is going to be negative 9, and negative 7, and negative 5. That was number 4. Number 7, calculator. To do these, the key here is when they ask to solve for them, the words either end in ed or th. This is so critical because when they're asking to be solved with a ed on the end of the word, it's on the left side of the decimal. When it's solved with a th, it's on the right side of the decimal. That's the key here. And then on A, we see there it says round to the nearest 10,000ths. You see the th? So we are talking about on the right side, and I'll just write this number up here: 104,062,535,27. All right, let's review the different placements here. It says 10,000ths, but this one is the tenths. This is the hundredths. This is the thousandths, and this is the 10,000ths. This is what they're asking us to solve for. So we have 104.062. And does 5 round up from the 3? No, it does not. So there's your answer for A. On B, we end with the ed or th. Look at that. Nearest 100. I'm going to write this number down. 413.0527. Ends with the ed, so that is on the left side of the decimal. And this placement here is the ones, this is the tens, and this is the hundreds. And that is what they're asking for. So we start off here. 4. Does the 1 round that up? It does not. And there is your answer, 400. Remember the ed and the th. And the next one we will have to use our calculator. It says round 2/7 to the nearest hundredths. th to the right side. How do we get the decimal out of 2/7? We divide the numerator by the denominator. So we punch into our calculator 2 divided by 7 equals, and I'm coming up with 0.2857142. And it says round to the nearest hundredths. This is the tenth, and this is the hundredth. So we're rounding to this. This is 0.20. Does a 5 round the 8 up? Yes, it does. 0.29. That was the problem number 7. Number 9 is the Pythagorean theorem. And here we go on our triangle. They give us the 6 here and the 4 and the S, and they asked us to solve for S. The key is always to look at it to see if they are giving us the hypotenuse or not. Which one of these numbers is the hypotenuse? This distance here opposite your square. So they gave us that, and so we square this. 6 times 6 is 36, and 4 times 4 is 16. Now, do we add or subtract? They gave us the hypotenuse, so we subtract. This is such a key. Try to remember that thoroughly. If they give us the hypotenuse, then we subtract. Here we go. So we got S is the square root of 20. Can that be reduced? 2, 10, 2, 5. Yes, it can. So our final answer is 2 to the square root of 5. That is number 9. Number 11. Given these points, and if you do not have a graph, which you don't, then just go back and use one of your graphs off of the old lesson. You can erase it, and just on number 11, just give us the final answer. Well, they give us the points of 4 and 3 and 7 and negative 2. Here we go. 1, 2, 3, 4. 1, 2, 3. 7. 1, 2, 3, 4, 5, 6, 7. Negative 2. Here's my 2 points. And across this. And remember, we square the corner. And we count our units. 1, 2, 3, 4, 5 on this side. 1, 2, 3, 3 on this side. They're asking for A and B. A is the slope, and the B is the distance. So the slope, is that a negative or a positive line, the slope? It is a negative. And it's rise over run. Here, from here to here is your rise, that's 5. And your run is sideways, so that's 5 over 3. Your slope is a negative 5 over 3. Now the distance between here is the same as we solved back on number 9. It's the Pythagorean theorem. In this case, do they give us a hypotenuse? They do not, so we solve like this. Square this. 5 times 5 is 25. 3 times 3 is 9. Do we add or subtract these two numbers? If they give us the hypotenuse, we subtract. They did not, so we add. 25 plus 9 is a 34. Can we reduce? That's going to be the square root of 34. Can we reduce that? 2 goes into 34. So no, we cannot. So this final answer is the square root of 34. That is on number 11. Number 20. Solve by graphing and check. Again, you must have a graph. You can go back and take one of your previous lessons and get your graph over that and just give us the final answer. Solve by graphing. Here's what they're asking us to graph. Y equals 2x and y equals negative x plus 6. The first one up here does not have a number out here, so it's understood to be a 0. And so we start off at 0 on our y line. Now this is a 2 over 1. Is it negative or positive? That is a positive. You agree with me? So we go up 2 and over 1, up 2 and over 1, up 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. There is our line. The next one we solve for is a positive 6. So we start off at a positive 6. 1, 2, 3, 4, 5, 6 on the y line. This is a negative, where we're going to be going down, and it's understood with nothing there to be a 1 over a 1. So we go down. I'll do multiple ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there is my line. Now then, where is the placement here where they cross? We have a 2, positive 2, and a 1, 2, 3, 4, and a 4, positive 4. There's your ordered pair. That is number 20. One more time on number 21. Graph on the number line. The function is integers. Write that on the top of your box to start with so we don't miss that. Now here's the original. Negative 2 greater than negative 2x and positive 2. Okay, we'll begin by moving the x to the left side where we want him at. So when we move him over, he's going to become a positive. Is that correct? So that's going to be a 2x. And then we can take this number, move it to the other side. That becomes a positive 2. So positive 2 plus 2 is a 4. Still have the 2 to get rid of. How do we get rid of the 2? This is multiplication, so we do the opposite. That's a divide. Now we end up with x greater than or equal to 2. Number line, this is a 0. We are only dealing with positives, so we'll just do this. This is a 2 and this is a 4. Our arrow is going to the right. And we are only dealing with integers also, and this is greater than or equal to 2. This is your first one, equal to, and then just the integers. Just the integers only. There is your final. That completes our lesson for today. If you have any other problems that you don't understand, you can call me or text me. I'll try to answer those for you. Have a wonderful, blessed day. And let me review one more time. Turn in at 2:30 today all your completed lessons from 95 to 100. Turn in your 2 completed reviews, both of those, for your bonus points. And then your completed test number 10. I think that's it. We'll see you tomorrow, and God bless your day.